So before going through this particular program, what we will do is we'll go through certain evaluation metrics, which will help you better understand these programs. So evaluation of regression models involves techniques like R-squared, adjusted R-squared, mean absolute error, and mean squared error. Out of this, number 1, 3, and 4 are popular. So R-squared already we have discussed is the given by this particular formula, or the one which we have seen over here. So either we can use this particular formula for R square, which is shown on the screen, or we can go for this particular formula for R square. Okay, it's basically the difference between the predicted and actual value. And we want to plot the best fit line. Now, in order to call this or calculate this R square using inbuilt Python libraries, developed Python libraries, we can say from sklearn.metrics import R2 score. And sklearn.metrics.R2 score as a function pass the parameters of actual value and predicted value. And it will display that what is the value of R square. It is closer to 1, it is good. It is not that close to 1, it is not a good trained model. Then adjusted R square is also there, which we'll not see that much in detail. Then we have mean absolute error, which is 1 upon n summation of difference in actual and predicted value. It is nothing but the mean of the errors. There are n points and we are taking the mean of the errors. So again, from sklearn.metrics import it and pass the true value and predicted value. Then mean squared error, it is what? We are taking the square of that error. In mean absolute error, we don't take the square. What are we taking? Absolute of that error. But in mean square standard mean square error, we are taking square of those errors. And similarly, we have to import it from sklearn.metrics. Now let us see this program. So always remember, your features should be a two-dimensional data structure. Two-dimensional data structure in the sense it should be a data frame or a matrix, that is 2D array, kind of. It should be two-dimensional because even if the feature is single, what we need to do is we need to pass it as a matrix. That means if we have a single feature x, which is equal to all of this, while passing it as a feature, we need to say x is equal to, this indicates the second dimension, this is the first dimension. So put all your values here, and this is the second dimension. Suppose there are two features, then we'll write it like this for feature 1, feature 2, separated by comma, and outside these are the external brackets. Okay, so pass it as a 2D one. That is why we are reshaping it. Then this is an object created of the linear regression class. Then call the fit method for the training examples, that is training feature and training label. And then predict it on some new x, predicted y. And then R2 score can be computed. And then you can print it. So this is how easily you can do it with the help of sklearn library. Simply create an object of the linear regression class, fit it by calling that method, and then you can do the prediction and you can see the metrics as well. Now, this is one small project, mini project, in which we are going to predict the student score based on the number of hours of his study. So the algorithm that we are using is linear regression. And here is the data set. We are going to read it. This is the way to read it. We have already seen. Now, whatever data set you read, this is available online, this data set. So whatever you read, it will get stored in DF. Number of hours and the score. Now, whatever this data set is, if you want to store it in another file, or if you want to see the whole data set stored in your own file, means in another file, then let that file name be hours versus score.csv type only, because the data which is present in this data frame has come from a CSV file, or it is CSV data. So store it in a CSV data file only. Otherwise, you may get certain errors in storing in different data file formats. So when you want to write it to a file, on the data frame, you call the to_CSV method and pass the name of the file with the extension .csv within double quotes as shown over here. You want to see the first 5 rows. Now, if you want to know the correlation between the hours and scores, that means you want to find out whether for X, given X, what is the relation with Y? Means if you increase X, is Y also increasing at the same rate? Or if you decrease X, is Y decreasing at a smaller rate? So such things, correlation can be identified. Now, correlation between any two variables always lies between -1 and 1. It may be less than equal to 1 or greater than equal to -1. So here you can see whenever we call df.corr, what will happen is you'll get a kind of structure in which whatever your column names are, suppose X and Y, those same column names will appear over here. And then in a tabular format, like X related with X, X related with Y, then Y related with X, and Y related with Y. So hours with hours, definitely they are the same column. So perfect positive correlation. Hours with score, this is the value. And similarly, scores with R will also be that particular value. See, this value and this value are same. And then this value is what? Score with scores. This will also be 1. Okay. Now this can be plotted with the help of a heat map. Heat map is nothing but, here again you have that same hours and score, hours and score. So score with hours, we have got the value black color. That means somewhere over here. That means 0.97 or 0.98 something. Let us check. See, 0.97 we had got. 0.97 for hours with score. And similarly for hours with score, this also is 0.97. Hours with hours is perfectly correlated, so it is 1. The shade of the color corresponds to these correlation values, okay? So I hope you understood this. Then using iLock, what you can do? You can access required number of rows, comma, required number of columns. So in iLock, you have to specify the index. That means if you just specify colon means all the rows, colon means all the columns, and -1 means you're excluding the last column. We know that in our data set, that is our data frame, we have hours and score. Excluding last column means exclude the score, rest everything is hours. That comes over here. This is the hours. And then Y is nothing but only the last column, that is scores column. That is why we are writing df of all the rows and just the last column, right? All rows, all columns except last one. This means all rows and last column. So this is the feature and label. And then you can print that as well. Then in terms of visualization, what you can do is you need to use matplotlib. Okay, so what we are going to do is either you use direct pandas function like df.plot and pass the x-axis as hours, y-axis as scores, and style O means the circles will be plotted. Some other style maybe cross marks will be plotted. So this is the style of plotting the data points on the graph. So either you can plot using the plot function on the data frame or using matplotlib.pyplot, you can import it as PLT. We have imported it as PLT. You can see here matplotlib.pyplot as PLT. That is why this PLT dot x label means what is the x-axis. Label here means what you want to name the axis, like hours. You want to name the y-axis as score. And what is the title of this plot? Scores versus hours. And you need to show it. So in one line, if you want to write this is PLT dot title, whatever title, dot show. This is also possible. So you'll get the plot. Now from sklearn.model selection, import train test split. What you're going to do over here is when you call this train test split function, you need to pass the features and the labels, that is x and y, and test size. Now, usually if our data frame is 100% of examples of x and y, then we can use suppose 80% for training, that means building the model, and remaining 20% like for testing. So whatever training we are using, suppose we are using, there are 10 values over here. So we have x1, y1, and so on up to, I'll write it a little well. Suppose we have x1, y1, x2, y2, x3, y3, and so on up to x10, y10. Then what will happen? These 10 values form the 100% of the data frame. What is 80% of this? 8 values. So x1, y1 to x8, y8, this 80% will be used for training. Remaining 20%, that is x9, y9, and x10, y10, these will be used for testing. Not necessary that we have to take serial wise only, sequentially first 8 and last 2, not necessary. That is why if we don't want to take it sequentially, what we can do is we need to give a random state. Now, random state means suppose x1, x2, x2, x4, x5, x6, x7, x8. So in our selection, what will happen is for our testing, we are taking 20%. Not necessarily x7, y7 and x8, y8 only have to be taken. What we can do is out of 8 possible examples, we are selecting any 2. 8C2 combination formula is what? We know that formula for NCR is n factorial upon r factorial into n minus r factorial. So 8C2 will become what? 8 factorial upon 2 factorial into 6 factorial. This will be what? 8 into 7 into 6 factorial upon 2 into 6 factorial. 6 factorial gets cancelled. 2 4s are 8, 7 4s are 28. Means there are 28 possibilities of selecting 2 features for the testing part. Now these two features can be anything, maybe y1 along with y3, or y5 along with y6, or maybe y4 with y1. Any set of examples can be taken. So maybe state 0 is y1 along with y3. Maybe state 1 is y4 along with y1. We don't know exactly whether state 0 is mapped to this and state 1 is mapped to this only. We can assume that some two features are taken, some two training examples are taken out of all the 8, and there are so many possibilities. Out of that, I want to consider any state, suppose 0. Or maybe I want to consider any state, suppose 7. Or maybe I want to consider any state, suppose 8. So there are 28 possible states. State 0 may be anything this. State 5 may be anything like this, y5 with y6. So any particular state we are taking. This concept of random state I already explained before. Now we are seeing it in short only. So this is the state. Okay. Then again, like previous example, sklearn.linear model, import linear regression, create an object of this class and fit the model based on the training examples. Now what you will do is, this regressor is the object of the linear regression class. This is my class and this is my object. I hope you know how to create an object of a class. So this line that we need to plot, what is the formula? Y is equal to mx plus c. That means m here is called as object dot coefficient COEF underscore. Similarly, c, that is y-intercept, is referenced by regressor dot intercept underscore. So these two are the variables or the state members of the linear regression class. So suppose linear regression is a class. Linear regression is a class. Then within this class, you may have certain variables like coefficient and intercept. And after performing the training of the model, these coefficient and intercept will get certain values, right? Internally, the computation will happen using gradient descent and all those cost function concepts. And coefficient and intercept will be calculated, which we can access from here now. And then we can print these values also. And now what we are doing is scatter the examples x and y and plot the line for given x. This is how you can read this function. Plot the line for given x and show it. So this is the line that we have derived after training, and these are our x and y from the data set. Now we have trained the model, we have plotted everything. Now what has to be done is, for new values of x, let us predict. Now we have trained based on the 80% of data. Now we can test based on the remaining 20% of data. So from the remaining 20%, which is stored in X test, all the X, that is all the features present in the test part, that you take it, do the prediction based on this, and whatever value of Y is predicted will be stored in YPRED. And then you can also create a data frame. What we have done till now, we have read the file and created a data frame. Now you can create a data frame by passing key value pairs. So why we have created a data frame here is just for simplicity in comparison. Whatever the Y test is, what is Y test? The actual values of Y present in the testing data set, and YPRED is the predicted values of Y for the X which was present in the testing data set. Okay. Let me clear it a little better. See, this is used for training and this is used for testing. So we have given the X train and we have given the Y train for training. Now, this is the X test. You pass this to the prediction function call, and whatever output you get, that is the Y pred. Now compare this predicted Y and the actual Y which is given to us in the dataset. So Y test along with Y pred will be compared, and that is what are the values over here for these keys. True value is the Y test and predicted value is the Y pred value. So you can see that the data frame has been plotted. So true value is what, 20. We have predicted it as 16 point something. True value is suppose 60. We have predicted it as 60 point something. So there is an error of 2 point something in this case. And here also some error of 4 point something in this case, right? So this is how you can predict. Now let us see how can we take user input in prediction. For example, you ask the user to input the number of hours of study. And if the input is greater than 0, we will try to perform the computation. Okay, so if now what you do is, we know that we have to take the input as a list. Okay, now you have to take it as a 2D structure. If it is a feature, label is always one only. Okay, so label is 1D, that is Y, whereas feature X is 2D. That is why whatever input we have taken, you need to reshape it. When you put reshape and pass the parameters -1, 1, this 1D structure of X gets converted to 2D automatically. These are the values that you need to pass. And now predict based on this number of hours. Do the prediction. Do the prediction based on this number of hours. Whatever prediction you get, you can print that. So this is the predicted score for given hours accepted as input from the user. And this is if the user enters some negative value of hours, which is an exception which we need to handle, which is in the else part, what we'll say, kindly enter positive value. So again, it will go inside the while loop and keep executing. If the value is positive, but suppose you are entering a string here by mistake, then it will go in exception handling and it will say, please enter a positive integer. This simple Python code, I hope you know this. So see, this is an example where enter the number pass 4 and the user has inputted and this is given as input and this is the predicted score 41.66. Okay, so if number of hours is 4, our prediction of score is 41.66. Let us kind of verify this. So if ours is 4, the score is 41.6 something. See, if the ours is 4, somewhere over here, it will come between these two. And 41.6 is also between these two, right? So we can see linearity between X proportional to Y. As X increases or decreases, Y increases, decreases respectively. Now we can verify the same using our metrics. If it is R2 score, we'll call the R2 score function. If it is mean absolute error, if it is mean squared error. Now, you have to pass every time same parameters, that is actual value of output and predicted value of output in all cases. And you can see here, R2 score value is 0.9, which is almost like 1. Hence, the model is trained well, accuracy is well, it is performing well. Mean absolute error is 4 point something. And mean squared error, since we are taking square, definitely it will be a little more. So these are the metrics which tells you that how much is the mean absolute error. That means the difference between predicted and actual y. And mean squared error gives you the square of the difference, which you put in the formula of MAE and MSE. So the model accuracy that we can say is whatever R2 score you get, okay, you can say that if you want to convert it into percentage, what you do, you multiply by 100. So you can say that 94.55% is the accuracy. Okay. Generally above 70, above 80, and depending upon the data and the sources, your accuracy is good. So this was about prediction of student score based on number of hours of his study. So this is it about linear regression. We have seen the intuition behind it, what is hypothesis, the algebra function, y is equal to mx plus c, then cost function. Then we also seen the gradient descent algorithm, manually how to solve it, how the computer solves it, how we can do it using Python libraries like sklearn and pandas and all. And we have seen some examples also run in Jupyter Notebook or Google Colab. So I hope this is sufficient for simple linear regression. Next, we'll see multiple linear regression and polynomial regression in the subsequent lectures. Thank you for your patient listening.